Drilling rigs like these bore or drill holes into the earth. Usually they drill to find oil and gas. They work both on land and offshore. Some are big and some are relatively small. Big rigs drill very deep holes, 20,000 feet, 7,000 meters or more. Small rigs may only drill to a few thousand feet or meters. People in the oil industry group rigs into 6 basic types. Land, jackup, platform, submersible, semi-submersible, and drill ship. A land rig drills on dry land. They're the most common rig. Light-duty rigs drill holes from about 3,000 to 5,000 feet deep, or 1,000 to 1,500 meters. Medium-duty rigs drill to depths ranging from about 4,000 to 10,000 feet, or 1,200 to 3,000 meters. Heavy-duty rigs drill holes from about 12,000 to 16,000 feet deep, or 3,500 to 5,000 meters. Ultra-heavy-duty rigs drill holes from about 18,000 to 25,000 feet or more, 5,500 to 7,500 meters or more. Crew members can move land rigs on trucks, tractors, trailers, barges, helicopters, heavy rolling gear, skids, and, in rare cases, on specialized air-pressurized equipment. Small, light-duty rigs are pretty simple to move. Ultra-heavy land rigs can be difficult to move. A jackup rig drills offshore wells. It has legs that support a deck and hull. When positioned over the drilling site, the bottom of the legs rest on the seafloor. Jackup rigs can drill in water depths ranging from a few feet or meters up to more than 400 feet, over 120 meters. Boats tow a jackup rig to a location with its legs up. Once the rig-up crew gets the legs firmly positioned on the bottom of the ocean, they can adjust and level the deck and hull height. A platform rig is an immobile offshore structure. That is, once built, it never moves from the drill site. Companies drill several wells from the platform. Platform rigs can be tender-assisted rig. The tender floats next to the rigid platform, which is firmly pinned to the seafloor. Many platform rigs do not have a tender. They are so large that they are self-contained. Big platform rigs include the steel jacket platform, the caisson type, and the concrete gravity type. In deep water, rig builders have to make platforms that yield to water and wind movements. Two compliant platform rigs are the guide tower and the tension leg. A submersible rig rests on the seafloor when it is drilling. Workers flood compartments that cause the rig to submerge and rest on the bottom. When ready to move, workers remove the water from the compartments. This makes the rig float. Boats can then tow the rig to the next site. Rig builders design submersibles to drill in shallow water and in water up to about 175 feet deep, a little over 50 meters. Submersible drilling rigs include the posted barge submersible, bottle-type submersible, and the Arctic submersible. A semi-submersible rig is a floating offshore drilling rig. It has pontoons and columns. When flooded with water, the pontoons cause the unit to partially submerge to a predetermined depth. The working equipment is assembled on deck. On the drill site, workers can either anchor the rig to the seafloor or use a system of thrusters and positioners to keep the rig over the hole. Here, they have it anchored. Crew members mount the wellhead and blowout preventers on the ocean floor. Special hollow pipe, called riser pipe, connects the top of the blowout preventer to the rig. In some cases, the crew uses thrusters to keep the rig over the hole. Called dynamic positioning, the thrusters, which are connected to an onboard computer, keep the rig in position. Some dynamically positioned semi-submersibles can drill in water depths of more than 7,500 feet, or over 2,200 meters. When keeping a rig over the hole, drilling crews use the term on station. Here's a semi-submersible rig loaded on a special carrier. The carrier vessel is moving the rig a far distance over the ocean. For shorter moves, the rig owner tows the rig to the drill site. Or some semi-submersibles are self-propelled. A drill ship is a self-propelled floating offshore drilling unit. It usually uses a subsea blowout control system similar to the one on a semi-submersible. Many pieces of equipment make up a rotary drilling rig. Part of it's on the surface, and part of it's underground, or subsurface. All the equipment has one main purpose: to put a bit at the bottom of the hole, where it can drill or make hole. To put the bit on the bottom, rig crew members screw it into a special pipe. The pipe is called the drill string. Crew members lower the drill string and attached bit into the hole. For the bit to drill, surface rig equipment has to rotate it, unless it's rotated by a mud motor. Equipment also has to put weight on it to force the bit's teeth, or cutters, into the formation. As the bit rotates, a circulating fluid has to take the drill cuttings away from the bit. Otherwise, the hole would clog up. The fluid which circulates is called drilling mud. To impart rotary motion to the drill string so that the bit can turn, either a top drive or a Kelly and rotary table system is used. Power is transferred from the surface down hole via the drill string. Some rigs rotate the drill string with a top drive unit. Top drives are expensive, but very efficient. Crew members can add drill pipe joints to the drill string very quickly and safely, and they can drill the well more efficiently, with less chance of sticking the drill string in the hole as compared with a Kelly and rotary table. A powerful motor turns a drive shaft, which is connected to the top drive. Crew members make up or attach the drill string to the drive shaft. The drive shaft turns the drill string and bit. Notice that the drill string goes through an opening in the rotary table. The table does not, however, rotate. A link system suspends the top drive unit from the rig's traveling block. Drilling mud enters the unit through the gooseneck to the rotary hose, the flexible line that conducts drilling mud from the pump. A motor and gearbox power the main drive shaft. The crew makes up the drill string to the drive shaft. The built-in inside blowout preventer, IBOP or safety valve, keeps fluids from backflowing up the drill string when the driller closes it. The crew uses the torque wrench assembly to make up and break out, connect and disconnect, the drill string. The elevator links suspend the elevator. The rig crew latches the elevator around the drill string to allow the top drive unit to lift it up or down. A Kelly drive bushing, a master bushing, and a rotary table rotate the drill string and bit on some rigs. The Kelly is a heavy tubular device. It usually has either 4 or 6 sides. That is, it either has a square or hexagonal cross-section. Square Kellys are less expensive than hexagonal ones, but the hex Kellys are stronger, so rigs drilling deep holes often use them. Whether 4 or 6-sided, crew members attach or make up the Kelly to the top joint of pipe in the drill string. The Kelly, 4-sided or square in this example, moves through a square opening in the Kelly drive bushing. The Kelly drive bushing mates with the master bushing, which the rotary table turns. This rotates the entire drill string and attached bit. The Kelly moves down as the hole deepens. There are many components which make up the drill string, as shown in this graphic. Drill pipe is strong but relatively lightweight pipe. Crew members attach it to a top drive or Kelly. Drill pipe forms the upper part of the drill string. Usually, the drill pipe rotates, which also rotates the bit. Each section of pipe is called a joint. Crew members screw together or make up several joints and put them into the hole as the bit drills. Drill pipe, as well as other tubulars, can be specified according to these characteristics: diameter, grades or strength, weights of steel, length. The diameter, weight, and strength used depends on the size of the hole, the depth of the well, and the well properties. Here is a typical oil field tally book. Many of these have sections in them which show standard drill pipe specifications. Drill pipe comes in 3 ranges of length. Range 1 is 18 to 22 feet, or 5.5 to 6.7 meters. Range 2 is 27 to 30 feet, or 8.2 to 9.1 meters. And range 3 is 38 to 45 feet, or 11.6 to 13.7 meters. The most common length is range 2, 27 to 30 feet, or 8.2 to 9.1 meters. Since a hole may be thousands of feet deep, crew members may connect together hundreds of joints of pipe. Drill pipe diameter can be as small as 2 3/8 inches, or 60.3 millimeters. This size weighs 4.85 pounds per foot, or 7.22 kilograms per meter. It can be as large as 6 5/8 inches, or 168.3 millimeters. This pipe weighs about 27.7 pounds per foot, or 41.21 kilograms per meter. However, 5-inch 127 millimeter drill pipe is one of the more common sizes. It weighs 19.5 pounds per foot, or 29.01 kilograms per meter. Normal drill pipe grades are E75, X95, G105, and S135. S135 is the strongest. The rig crew makes up or connects drill pipe, using threaded sections of each end of the drill pipe. These threaded sections are tool joints. The female tool joint is the box end of the drill pipe. The male tool joint is the pin end. Tool joints come in several sizes and types. Tool joint threads are rugged because the crew makes them up and breaks them out over and over during the drilling process. But they have to take care not to damage them. Proper care and handling of drill pipe and other oiled field tubulars can prevent corrosion later in the life of the well. Crew members make up heavy wall drill pipe in the drill string below the drill pipe. Heavy-walled drill pipe, often called heavyweight drill pipe, is made up between the drill pipe and drill collars. Heavy-walled drill pipe is used to provide a transition between the limber drill pipe and the drill collars, which are quite stiff. The use of heavy-walled drill pipe reduces the stress that stiff drill collars put on the drill string. As a result, heavy-walled drill pipe reduces fatigue on the regular drill pipe. It also helps keep the drill pipe in tension. And may sometimes provide weight on the bit, just as drill collars do, especially in directional drilling. Heavy-walled drill pipe, or heavyweight drill pipe, has thicker walls and longer tool joints than standard drill pipe. The longer tool joints reduce wear on the pipe's body. They keep the body away from the side of the hole. The wear pad also prevents wear. It keeps the middle of the pipe's body away from the side of the hole. Spiral heavy wall drill pipe is another type of heavy wall drill pipe. Spiral heavy walled drill pipe has a spiral groove in the pipe's body. Regular heavy wall drill pipe has no groove. But spiral heavy walled pipe has no wear pad. When spiral heavy walled pipe contacts the side of the hole, only a small part of the pipe body actually touches it. In fact, only the part of the pipe body between the spiral groove touches it. The groove does not touch the wall of the hole, thus reducing the surface contact area. Reducing the surface contact area helps prevent the pipe from sticking. Crew members make up drill collars at the bottom of the drill string. Drill collars have thick walls and are very heavy. They put weight on the bit to make the bit's cutters bite into the rock and drill. Drill collars range in diameter from 3 to 12 inches, or 76.2 to 304.8 millimeters. They range in weight from about 650 to 11,500 pounds, or 300 to 5,100 kilograms. This particular 6-inch drill collar weighs about 2,700 pounds, 1,225 kilograms. Since the crew usually installs several drill collars, you can see that a bit requires a lot of weight to drill properly. How much weight depends on the type of formation and the size and type of bit, but it can be several thousands of pounds. Drill collars are normally 30 or 31 feet, 9.14 or 9.45 meters long. And have a threaded female connection at one end. And a threaded male connection at the other end. It's an interesting observation that in the drilling business, tubular equipment diameters and hole diameters are almost always measured in inches, but lengths are usually measured in either meters or feet. Let's see how well you've been paying attention. In the section on drill pipe, we told you what the names of the male and female connections were called in oil field terminology. Using the mouse, label the photo of the drill collar, and then press Accept to see if you're right. No, that's incorrect. That's right. Some drill collars are slick. They have a smooth wall. Some have a spiral groove machined into their wall. The rig uses slick collars under normal circumstances. The rig uses spiral collars when drilling in formations where the collars may stick to the wall of the hole. Large diameter collars are fairly close to the diameter of the well bore. Under certain circumstances, they can contact the wall of the well bore and get stuck. The spiral in the drill collar helps prevent the collar from sticking to the wall by reducing its surface contact area. Crossover subs go in the drill string between the drill pipe and drill collars, and at other points. A crossover sub has a special box and pin threads. Manufacturers design them to join parts of the drill string that have different thread designs. For example, a drill pipe's pin may not screw directly into a drill collar's box. So crew members make up a crossover sub in the last joint of the drill pipe, where it joins the first drill collar joint. The crossover sub's box threads match the drill pipe's pin threads. And the crossover sub's pin threads match the drill collar's box threads. These matching threads allow crew members to join the drill pipe string to the drill collar string. Drilling rigs typically have a large variety of crossover subs. Crew members often make up reamers and stabilizers in the drill collar string. Usually they place one or more at various points in the drill collar string near the bottom. Reamers and stabilizers hold the drill collars off the wall of the hole to prevent wear on the collars. But even more important, reamers and stabilizers help guide the bit in the direction it should drill. Reamers have cutters on rollers that actually cut the rock they contact. Stabilizers have blades that touch the wall of the hole, but do not cut it. Notice the lower portion of the drill string. It includes the bit, drill collars, stabilizers or reamers, and heavy wall drill pipe. Crew members call this part of the drill string the bottom hole assembly, or BHA for short. They can make up many different BHAs. Which one depends on the type of formation, whether the rig's drilling a straight or directional hole, and so on. The pipe rack is not part of the drill string, but plays an important supporting role. The rig crew cannot put drill pipe and collars on the ground or a deck. Dirt and debris would ruin them, so they store them on the pipe rack. They also clean and inspect the drill string and other tubulars, or pipe, on the rack. As we discussed in the last section, crew members install the bit on the bottom drill collar. Two kinds of bits are roller cone bits and fixed cutter bits. Fixed cutter bits are also called fixed head bits. Roller cone bits usually have three cone-shaped devices with teeth or cutters. As the bit rotates, the cone and cutters rotate to drill ahead. Fixed head bits also have cutters, but manufacturers embed them in the bit's head. The bit's head moves only when the bit rotates. It has no moving parts, like the cones on a roller cone bit. Both roller cone bits and fixed head bits come in sizes ranging from only 2 or 3 inches, or about 50 to 75 millimeters in diameter, to more than 36 inches, about a meter in diameter. Two basic kinds of roller cone bits are available. One has steel teeth, and the other has tungsten carbide inserts. On a steel tooth bit, also called a mill tooth bit, the manufacturer mills or forges the teeth out of the steel that makes up the cone. Steel tooth bits are the least expensive bits. When used properly, they can make hole for many hours. Manufacturers design steel tooth bits to drill soft, medium, and hard formations. With tungsten carbide insert bits, the manufacturer presses very hard tungsten carbide buttons, or inserts, into holes drilled into the bit's cones. Tungsten carbide is a very hard metal. Tungsten carbide insert bits cost more than steel tooth bits. However, they usually last longer because tungsten carbide is more resistant to wear than steel. In general, tungsten carbide insert bits drill medium to extremely hard formations, but can also drill soft formations. Soft formation bits usually drill best with a moderate amount of weight and high rotary speeds. Hard formation bits, on the other hand, usually drill best with high weight and moderate rotary speeds. Three types of fixed cutter bits are available. Polycrystalline diamond compact, or PDC bits, diamond bits, and core bits. This PDC bit has cutters made from man-made diamond crystals and tungsten carbide. Each diamond and tungsten carbide cutter is called a compact. Manufacturers place the compacts in the head of the bit. As the bit rotates over the rock, the compact shears it. PDC bits are very expensive. However, when used properly, they can drill soft, medium, or hard formations for several hours without failing. A compact's PDC layer is very strong and wear-resistant. Manufacturers bond the diamond crystals to the tungsten carbide backing under high pressure and temperature. The tungsten carbide backing gives the compact high impact strength. It also reinforces the wear-resistant properties of the cutters. Manufacturers make diamond bits from industrial diamonds. The diamonds are the bit's cutters. Diamonds are one of the hardest substances. A diamond bit breaks down the rock during drilling by either compressing it, shearing it, or grinding it, as shown in this animation. Here, the diamond is acting like sandpaper, wearing the rock away. They embed the diamonds into the metal matrix that makes up the head of the bit. Diamond bits are expensive. When properly used, however, diamond bits can drill for many, many hours without failing. Crew members run a core bit and barrel when a geologist wants a core sample of the formation being drilled. A core bit is normally a fixed-head PDC, or diamond bit. It has a hole in the middle. This opening allows the bit to cut the core. Diamonds, or PDCs, line the opening and sides of the bit. The rig crew fits the core to a core barrel. The core barrel is a special tube, usually about 30 to 90 feet or 9 to 27 meters long. They run the core barrel at the bottom of the drill string. It collects the core cut by the core bit. Cores allow geologists to take a look at an actual sample of the formation rock. From the sample, they can often tell whether the well will be productive. Special equipment in the drill string includes drilling jars, measurement while drilling, or MWD tools, and mud motors. The rig crew installs a drilling jar in the drill string if there is a concern of becoming stuck. Drilling jars are usually made up in the upper part of the bottom hole assembly, with drill collars placed above and below the jars. When activated, a drilling jar provides a heavy blow to the stuck portion of the drill string below the jar. Often, the blow delivered by the jar is enough to knock loose the stuck string. To create a jarring blow up with a hydraulic jar, the driller lowers the drill string to cock the jar. Then, the driller applies an upward pull. The upward pull puts the up jar in tension and allows the jar trip mechanism to slowly bleed. Eventually, the jar trips when the hydraulic oil bleeds past the ports. The drill string contracts, rapidly accelerating the bottom hole assembly above the jars. When it reaches full stroke, the jar mechanism suddenly stops the motion energy of the string. When the motion suddenly stops, it converts the kinetic energy, or energy in motion, into impact force on the stuck point. This heavy upward blow may free the stuck string below the jar. Measurement while drilling, MWD tools are a big help to the driller as the bit drills. Crew members usually place the tool in a special drill collar close to the bit. MWD tools sense downhole conditions and transmit them to the surface. There, the driller monitors the conditions in real time. Most MWD tools create pulses in the drilling mud. These pulses carry the downhole information up the drill string to the surface. Information collected by an MWD tool includes rock properties, the direction the bit is drilling, torque, and weight on bit. Often, when drilling a directional or horizontal well, a mud motor is made up in the bottom of the drill string, just above the bit, as shown here. It's called a mud motor because drilling mud rotates the bit. That is, when using a mud motor, only the bit rotates, not the rest of the drill string. Mud pumped down the drill string enters the top of the mud motor. When pressurized drilling fluid is forced between the elastic stator and the eccentric steel rotor, a torque is applied which causes the rotor to rotate. The rotor is connected to a drive shaft, which is connected to the bit. Note that all the drill string does not rotate. Sometimes a well is drilled at an angle. This is called a directional well. The well is steered at an angle specified in the drilling program for many different reasons. For example, they may drill directionally sometimes if the oil or gas reservoir does not lie directly under the rig site. Horizontal wells are drilled for many different reasons. Certain reservoirs can be produced better if a horizontal portion of the well passes through the formation. The transition to the horizontal segment of the well begins at some point in the vertical portion of the well bore, as shown here. This point is termed the kickoff point. The horizontal segment of the well can extend for several thousand feet. Specialized drilling equipment and techniques are required to drill horizontal wells. Select and drag the rig icon to its appropriate location on the chart. Sorry, that's incorrect. You may review this material now by selecting the Review option. Sorry, that's incorrect. You may review this material now by selecting the Review option. That's correct. These are joints of drill pipe on a pipe rack. When crew members join several pipes together to make a drill string, the pipes A. Put weight on the bit, B. Transfer rotary motion to the bit, C. Conduct drilling mud down the hole, D. Both B and C, or E. That's correct. The drill pipe transfers rotary motion to the bit and also conducts drilling mud down the hole. What is this? A. Top drive, B. Core barrel, C. Jar, or D. Kelly. That's correct. This is a Kelly with the Kelly bushing. Identify the equipment highlighted. A. Kelly and rotary system, B. Reamer and stabilizer, C. rotary table, or D, top drive? That's correct. This is a top drive unit. The drill collar on the right is a spiral drill collar. Why does it have a spiral? A. The spiral allows it to drill into the formation. B. The spiral makes it slicker. C. The spiral helps keep it from getting stuck. Or D. None of the above. That's correct. Spiral drill collars have less contact surface area. Tungsten carbide bits have tungsten carbide inserts that are harder than diamond. A. True, or B. False. That's correct. Diamond is harder than tungsten carbide. In fact, diamond is one of the hardest substances known. Which drill string component is the stabilizer? That's correct. This is a fixed blade stabilizer. The other tool shown is a roller reamer. The common characteristic of almost all drilling rigs is that they A. All drill with Kellys. B. Are capable of being moved or mobilized. C. All drill with top drives. Or D. All can be used on land. Sorry, that's incorrect. Drilling rigs need to be mobile so that they can be moved to new work locations. You may review this material now by selecting. That's correct. Almost all drilling rigs are capable of being moved so that new wells can be drilled. This jackup rig is A. Under tow, B. Jacking up, or C. Fully positioned in the working mode. That's correct. This jackup is on location in working mode. True or false? A platform rig can drill many wells from a single offshore platform. A. True, or B. False. That's correct. Usually, platforms have several wells. When the lower bottom hole assembly becomes stuck, what tool can be used to free it? A. Stabilizer, B. Reamer, C. Jar, or D. Crossover. That's correct. A jar is a useful tool for freeing stuck tubulars.